voting joystick for accessible voting machines. Our sponsor is Michigan State University Research Center for Persons with Disabilities. And as an introduction to our team, my name is Joy Yang, and I'm an electrical engineer.
I'm Graham Pence, I'm also an electrical engineer.
I'm Tyler Dennis, I'm also an electrical engineer.
I'm Yang Chen, I'm also an electrical engineer.
I'm Mehmet Rashidian, I'm a computer engineer.
So today we will be talking about the background, the design specifications, design solutions, about our interface, the project management, and also the summary of our project. So our project is a dual-axis joystick that's used in a voting ballot on a computer system when you go to a voting booth to vote. So this will help many individuals with dexterity, disabilities, and limitations in a sense that they will be able to vote more efficiently given the time constraint that they have compared to a standard user, and also without significant discomfort. There have been previous voting machines that have been implemented and commercialized across the voting booths across the United States. However, they do have some problems in a sense that they're not really user-friendly in a sense that they take too long to vote. They also are not easily adaptable for different people with different abilities. And also, their interface is specific to the location of the voting booth. So what that means is that you may have one device that's compatible in one voting precinct, but when you take it over to a different voting precinct, it may not be compatible anymore. But our joystick, we're programming it to be used universally. So what we do is we interface this with the voting software. So this is a photo of one of the previous voting devices that I talked about. This has been commercialized, implemented across the United States. People use this all the time when they go to vote. However, what this 1 to 2 button device, it's called a dual rocket switch. So however, this switch is not optimal. It has been tested with people without disabilities, and it's taken them 12,000 voting presses without making any mistakes, and also they do it within 40 minutes. So that's actually a lot of time to be spent on voting. And if you're disabled, you're going to be spending about 4 times amount just to vote using this device. Another downside of this device is that when you want to write in your ballot when your candidate is not selected, what you have to do is you have to scroll through the entire alphabet from A to Z, and you have to manually select it. So one of the disadvantages of this dual rocket switch is that when you go back, you actually can't because there's not a backspace button. So you have to go through the entire alphabet quite a few times just to select the candidate that you want. So all of these are issues, and then Graham will be talking about how we are going to solve these issues.
So after looking at all the problems that we had in the past with voting machines, we decided we would create something new. It came to our attention that we were going to build a joystick. And the people we're trying to focus on are people with motor disabilities, dexterity issues, problems where they can't handle things well, they shake possibly, for example, people with Parkinson's disease, cerebral palsy. So we're going to focus on building and constructing a very durable structure that they can use and wear and tear on, it's going to still stay strong. And it's also going to be relatively easy and learn to use, and very easy to use. A lot of previous voting machines are up in the corner. They're very difficult to understand. It may take 10 to 20 minutes just to even understand how it works. It's going to be very simple, very few buttons. It's going to be double axis so that the user can go back and forth and up and down. Because the ballot's going to be not one dimension, it's going to be up and down. It's going to have multiple users and different people that you can vote for. So a feature that we want to implement is force feedback. We do this by controlling the amount of force it takes to move up and down and up and right. We do this and this is good because a lot of users who have problems shaking, they may go all over the place with their ballot. So we want them to have a secure feeling when they are on a selection in a position that they actually feel comfortable with, and it takes a little bit of force to go to the next position. So we kind of want like our ballot system to have like a square rectangular box section for it, so they really know where their position's at. Also, we can set, if we choose to, you can set the number of detents on a joystick. So if we're at position 1 and there's a 5x5 grid, you can position the joystick to stay in that set position, but it won't go back to the original position. Although this detenting probably wouldn't work that well for our case because the number of people you can vote for is usually within a set number, so probably won't use detenting as much. So yeah, force feedback is great. It's very great. It's going to let us have a good feeling of being locked in a good position. So this is a picture here of a force feedback joystick. How it works is the microprocessor sends electrical signals to the position sensor. This is all based on the programming within the processor, and the motor is activated by how much resistance you put on it, and it will have the joystick either rock back and forth with the pulley system. So basically you can set it for how much you actually really want. The motor is actually going to be an actuator that we're going to use, which we'll need 2 of them for the X and Y axis. We decided to go with the standard USB interface. It seems like it's the best universal way of connecting to different objects. So basically we can use this to hook up to computers, iPads. People have ideas of creating iPad voting systems. For our case, we'll mostly be focusing on HTML files to transfer our voting and joystick software together. It's also going to allow us to access the internet so we can connect to joystick to mouse programming and joystick to keyboard. So a user can use a joystick as well as a keyboard at the same time, or we can set up programming to connect directly with the keyboard interface. At first, they actually wanted us to build a single-axis joystick. We decided not to do that after talking with our sponsor, Steve, and also after seeing the ballot. There's just no way that you can go through and have a single axis. I mean, the reason for wanting a single axis is just less mistakes, you know. We want it to be as simple as possible so the user can just go one way and not have any problems and not click the wrong thing. But there's just no possible way for that, so we're going to go double axis. And hopefully it's going to minimize the voting time compared to any other feature that's out there, and allow the user to freely go to any selection they want to while going through a ballot. And then lastly, we want to have the visual appearance of this to look, aesthetically pleasing. We're going to custom design everything from the exterior base of the circuit to the actual joystick. It can be a basic model, rounded on top, so the person has good control of it, and we're going to make it durable, probably like a metallic type substance. And we only plan to implement only 1 or 2 buttons. The less, the better. We don't really want too many issues with people making mistakes. So next, Tyler's going to talk about microprocessors and design solutions.
Okay, a couple of the key electromechanical components of our joystick are actuators and force-sensitive resistors. We're going to use these to make our force feedback system. Basically, how it's going to operate is we're going to have one actuator in the Y direction, in the Y-axis, and one in the X-axis, and also a force-sensitive resistor for each axis as well. And the idea here is that the user is going to exhibit a force on the joystick, and as more force is applied, the resistance of the force-sensitive resistor will change. This will change the electrical signal that's sent to our microcontroller, and we can use this to set kind of a threshold force that's required to fire the actuators and move the joystick to the desired position. The microcontroller that we're going to use is called the Arduino Leonardo. It's based on, you can program it with C and C++. The great thing about this is we can actually adapt our joystick to users with very diverse ability levels. So say one person requires a lot more force feedback to kind of keep their hands steady. Say if they make a lot of uncontrolled jerking motions, that force feedback can be used to keep the joystick more steady and prevent them from selecting a candidate that they don't want. Also, maybe if someone needs a little bit more assistance, we can program the drivers to allow a smaller force to be required to activate the actuators. So this will just allow us to cover a very large range of abilities. As for our input button, we're going to make that completely separate from the joystick shaft itself. If we had the button on the shaft, there's a chance that people who can't really control themselves that well, they would accidentally press the button when they don't want to. So we thought it would be best to just have that wired separately off to the side so that they don't make that mistake. A couple reasons for choosing the Arduino Leonardo. It's affordable. We got ours for $25 and it has all the features we need, plenty of inputs and outputs so that we can interface between the electromechanical components in the board. It's also very small. This is great for us because we have to create a mechanical housing for our design and make it pretty small itself. So this will give us some versatility when it comes to actually placing the board within our design. It's also recognized as a generic keyboard and mouse, and there have been several libraries created for the Leonardo that give it keyboard and mouse functionality. So that's going to streamline the process when it comes to creating the drivers for our joystick and just make things less complicated. There are a couple power requirements. Leonardo gives us a couple of options here. We can either power the joystick through micro USB because the board actually includes a micro USB port right on it. So you can literally just plug it in and receive power and start working with Leonardo right away through micro USB. But that likely won't be enough for us, so we're going to have to go to an external power supply, which Leonardo also supports. There's a couple limitations on this. The recommended voltage range is 7 and 12 volts. That's where the board will operate best. But there are maximum and minimum limits. Below 6, you're not going to get enough power to actually power the board itself. And over 20 volts, there's a good chance that you're going to burn out your board if you connect it. So if we want to go that route, we just have to develop or get an AC to DC converter. Another important thing to mention is how we're going to test our joystick. There's actually a group on campus called the UARC. They work with people of different abilities to kind of research like usability and accessibility things, kind of like what we're talking about, making things more accessible for people with varying abilities. And so pretty much what we can do is take our design over there, and there will be several people who are willing to test our design. We can use them to get feedback and use this feedback to improve our design based on people who accurately represent the target market we're going for here. And they will be able to test this joystick on the HTML voting software that we're trying to interface our joystick with, and Yangi is going to talk more about that.
Thank you, Tyler. And I will briefly talk about how we're gonna use the testing interface to adjust our joystick movement. At the beginning of our project, we had two ballots to choose. The first one is Anywhere ballot. The second one is developed by Georgia Tech. Our team decides to use the Georgia Tech ballot since we are building a double-access joystick. This ballot fulfills our requirements better than the first one, and I will give you more details in the following slides. And here's the picture of our Anywhere ballot, which is our first option. And using this ballot, voters can only control and scroll down the pages by a mouse. If we work on this ballot, we have two options. The first one is we have to reprogram our joystick to make it work as a mouse. In that way, our joysticks, the area of our joystick movement will increase. That will result in higher statistics of errors while testing. So that's and another option is if we insist on two-axis movement for our joystick, we have to reprogramming the whole input of this ballot page by page. That will also complicate our programming of the ballot. And here's the Georgia Tech ballot. As you can see from here, this ballot provides multiple ways of input, and we are going to use this one, which is called 5 buttons plus columns, which means voters can use arrow buttons and enter button on the keyboard to use this software. Yeah, and if instead of reprogramming the whole ways of input, we can just take advantage of the existing input. This will save us a lot of time in reprogramming the whole vote ballot, and we can devote more energy in hardware improvement. And however, the Georgia Tech ballot is not perfect as well, and we also have some technical issues need to solve. Here's one page of our Georgia Tech ballot. As you can see, there are over 44 choices on this page, and the bottom line of our options cannot be displayed. Another problem is sometimes you cannot use arrow buttons to scroll down pages. And the most important problem of this voting ballot is voters cannot open this ballot by using some browsers like Internet Explorer. And this problem would take us a lot of time to fix it, since we have to reprogram a lot of details and test them by using different browsers over and over till it works. And after we finish after we resolve our technical issues, well, if we still have time left during this semester, we will customize our voting ballot interface. Currently, the next arrow button and the enter button works as the same function, which is selecting the choice. So we are going to make arrow buttons works only as selecting directions, so that our voters won't mistakenly choose some options while they just want to move to the right. We will also highlight the off selections while to give them a visual cue that reflects their current selections. And now we will hand this over to Vedant, and he's going to talk about project management.
Thank you, Yang Yi. I'm going to give you some feedback about the original this group. This group consists of 5 people, and I'm going to talk about the technical rules that we assigned to everyone. Yang Yi Chen doing the electrical design of this project. She will be making the circuits, the breadboard, and making an interface between those two. Tyler Dennis working on software testing support and basically working on the code that you're going to implement on this Arduino Leonardo and making an interface with HTML file that they have online. Graham Pence working on the electrical design of this project, making an interface between the Arduino Leonardo and a breadboard that we have. Basically, he's going to be cooperating with Yang Yi Chen in this group. Next person is me, myself, working on software design of this project, basically helping Tyler Dennis working on Arduino Leonardo code, and also the HTML file that we have been provided by Georgia Tech. Joy Young, she'll be doing the mechanical design of this project, basically working on the body of this joystick, making an interface between the handle and actuator of this joystick. I want to talk a little bit about the non-technical rules that we have assigned to everyone. Yang Yi Chen doing the lab coordinating, Tyler Dennis doing the documentation, web designing is done by Graham Pence, and myself, I'm going to be doing project managing of this project, and Joy Young doing the presentation prep. Our project is going to be developed in 4 phases. Phase 1 is the research. Basically, after we were chose to do this project, the first thing we did, we went online and just looked for existing designs, see how they work and how they can be connected to different computers, and how their software is working with the computer and interacting with it. So we looked at existing designs and problems that they had to improve our product. Phase 2 is product creation, which is one of the most important parts of this project, basically. We looked at the parts and we researched for parts, different parts like Arduino Leonardo and the board that we're going to be using in this project. And after we looked at different parts that we needed, Yang Yi, who's the lab coordinator, did the ordering of these parts. Phase 3 is prototype development, basically putting all the parts together and making the prototype for this project. And last phase, which is phase 4, is pilot testing, which is going to be roughly around the last 20 days of the semester. We're going to be testing our device, giving it we're gonna give it around to people with disabilities to test it and come up with ideas, give us some feedback if they have any problem with them, so we can like work on it a little bit more. And for the last few days, we could probably fix our errors. Budget justification, we have a budget of $500, which is provided by our sponsor. $150 is dedicated to force feedback joystick that we already spent that, I think, on joystick that we bought here and there because we needed to look at a few of them, work on them, and test them, see how they work, and basically sample them. $130 for microcontrollers. Arduino Leonardo and PCB board. Arduino Leonardo is, we gave you feedback about it. I actually tailored it, and a PC board that we're actually working on it right now to get some results from it. $220 for electromechanical components, like the actuator and system that's actually used for to interact with Arduino Leonardo. Again, I want to summarize everything for you guys. Voting system in history, we talked about it. Jody Young talked about it, and actually it's about the existing designs that we have and the problems they have right now with the designs that already exist. Existing designs like the two-button voting system that is already existing in voting booths, and people are really having problems with them. Next part, design specifications. Actually, we've talked about it, about like actuators and how they interact with the microcontroller design solutions. We have two design solutions, Arduino Leonardo and force feedback. Basically, we need to work them together. So, like, we have to make an interface between Arduino Leonardo and force feedback of this joystick. Last part, I talked about personal timeline and budget, which was the end of this presentation. And thank you so much for your time. Any questions?
Thank you. Are there questions? Oh, I always have a question. So you're going to have the force feedback on the joystick. Is that going to just be set at one setting, or will there be a way for the user to adjust that depending on what their need is?
Yeah, we'll include in the drivers a way to adjust that, just so we can accompany the needs of people of various abilities. So that they'll be able to change the necessary force required to fire the actuators.
Any other questions? If not, thank you again. Team 8. Set up.
So I think I'm going to talk about MIT's already used by it. I think I'm going to also talk about dredge process. If you do law, ours might be. Well, I didn't check this because about that example I talked about